I'm just
direct
gonna
variation?
record the,
What's a direct
White
variation?
oboes.
and see if it'll work for her.
What's number 3?
What's the Alg Lesson English right now?
Oh wait, I remember it, I think.
Low.
So,
I'll just say when I was
Gerard, 7th grade got second, right?
I don't know.
Yeah, they got
Did
second.
we get second?
No,
So
we didn't got
Melina
first.
won. I hadn't even thought about that. You gotta go to the restroom, you mean?
No, she has to eat.
They lost 4 games, but 3 of them were out of the league.
Right,
Wait, why are you recording?
for her, so she can see the bell work and stuff.
Oh shoot, I forgot to do this.
I think they should just do it in Madden.
Okay.
I had to go in Madden.
Direct variation is y equals kx. Talked yesterday how k can also just simply be m. It's okay if you put m for slope. We talked about k being a constant of variation. But anyway, there you go. What point does it always go through? An origin. Direct variation goes through the origin of 0, 0. And then suppose y varies directly. This is what we did on the worksheet, where we take our y and our x that are related or have a direct connection, and we write that our m, or in this case k, is 15 over 12, which reduces to 5 over 4. So we have a direct variation of y equals 5/4 x, and then they want us to find the value when x is 32. So we have y equals 5/4 times 32 over 1. You can do a little reducing there. 1, that's 8. Yeah, if you set some gauges. Is he not here?
Yeah,
Yeah, just go ahead and set there. And then 5 times 8 is 40, which most of you had there, it looks like. So good job. All right, so we are ready then to go ahead and get started on 3-5. So open your books to there. I don't have it on the screen.
Oh, Bram.
Haven't needed that lately.
Yeah, this year.
Should I just keep it for this?
No, I think I might hide it.
Okay. I didn't put on the lesson that very beginning part, the arithmetic sequence of linear functions that's at the top. Yes, ma'am? Delete the app, install it maybe? Or have you restarted your iPad? I delete the app and restart it. See if you can get right back in. So the wildness. During a 2,000 meter race, the coach of a women's crew team recorded the team's times at several intervals. At 400 is a 132, at 800 is 304, 1200 is 436, and 1600 was 608. Okay, and then they completed it in the 2000 at 740. So then we get to. Do I not even have the recognize thing on there? No. Okay, so just looking at your book, it says recognizing arithmetic sequences. Okay, a sequence is when we have a list of numbers that have a pattern to get from one to the next. Okay, if you are adding or subtracting to get from one point to the next, then that's called an arithmetic sequence. Okay, so whenever you put this stuff into the chart, which you can see here, 400, 132, 800, so on and so forth. Everybody seeing that in the book? Because I don't have it up there. You can see that they show that the time has a difference of 1 minute and 32 seconds between each interval, doesn't it? Yes, ma'am. Was it capital? It's your regular old
Capital A.
22 whatever, and there was a capital A. So you can see there how they show that difference from time is an interval of 132. You're adding 132 each time. That means that this is an arithmetic sequence. Okay? You're adding or subtracting. And then so since there is a difference between successive terms that is constant or the same, it's an arithmetic sequence. The difference between the terms is a common difference. So that 1 minute and 32 seconds is what you'd call the common difference. And we'll need to know what that term or that idea to be able to write an equation here in just a little bit. Okay? Now I think we're good on this. Nope. I got this thing all turned around. Here we go. So there you go. You can see on this first example, 3, 5, 7, 9, the common difference would be 2, and because we're adding 2 to get to each one. On this one, 33 to 29 is the difference of 4, so the common difference is -4. Right? And they're arithmetic sequences because we're adding or subtracting between them.
Please excuse this interruption. I have several students I need to see in the office. Lakeland Arthur, Emma Kendall, Addison McCarley, Jocelyn Clift, Trenton Smith, and Carson Lambkin. Thank you.
Okay, is this a sequence, first of all? Kobe? Why?
Because it subtracts 2.
Are you sure it's subtracting 2?
Oh.
Yeah, you're adding since you're on the negatives. So it has a common difference of 2, so it is a arithmetic sequence. Okay. How about on the left, on A? Yeah?
Yes.
Why?
Because you're adding
On the left.
oh.
Mr. Clevenger,
Yes, ma'am?
I need Allie David, please. She's leaving. Thank
Okay.
you.
We're recording it, so hopefully I can get it
Okay.
somewhere.
Or if she gets sick, Caitlin can
You
just
said
do the exact same thing.
I said 12 or
So what are we doing on those?
you're adding.
You're adding 2 to each of those, so you have a common difference of 2. How about B? What do you think on that one, John?
The first 3, you're adding 1/8, and then that last one you're adding 1/16. So
Is that right? I honestly don't know.
it's like
Yeah, it is.
In the book it says.
So I'm going to write them all, because it says in the book. Good point. Guess I could just scroll down. But if we get a common denominator here, that is 8/16, 10/16, 12/16, and then 13/16. So it does not have the common difference of 2/16. Okay? And with those fractions, you need that common denominator on that. Okay. Determine whether this is a sequence or not, please. Hold up 1, 2, or 3. Faith, which one is it?
Hey.
Wake up. Quit eating in class.
What cheese eat? I can't hear you. She says it's 30.
3? No.
No,
Corey?
it's 2.
2. Because we're going from 2 to 4 is plus 2, plus 4, plus 2, plus 2. That plus 4 changes that up. There's not a 6 in there, is it?
Oh,
It's
wait,
not
what was
multiple.
that?
It's not multiplying by 3.
She has her fingers are.
Oh, so the arithmetic or whatever.
Arithmetic sequence is addition.
There is.
Just bring it, and I hope to add. the
Adding,
next
this would have needed 6 here, so
Oh,
we were
okay,
going
I see.
adding to, adding to, adding to, adding to. Okay. So that part's not very tough. What's this? Is this the same thing? No. Find the next 3 terms in this arithmetic sequence.
Oh.
What is the common difference, first of all, Grace? Minusing 6. So -3 minus 6 would give us our next term of -9. Then -6 again would be -15. And then -21. Alright, you're just applying that rule to the next terms. You with me, Cope?
Understanding.
Now, what we're going to get into here, I believe on this part, well, I'm not going to have you do this individually, but what's the common difference? Caitlin? Subtracting 3. So it'd be -30. Aren't you subtracting 3? It's going the wrong way as far as that it's subtracting 3. Okay, so you can get to that. All right, here's what's very interesting, and this is the part that could be somewhat difficult for you. If you can get this little formula down, it'll make more sense. So what we're going to try to figure out is a formula that will represent whatever sequence we have. So that if I wanted, say, the 88th term, right here we haven't gone more than 6 or 7 terms in a row, right? But if I wanted to know what the 88th term would be, I wouldn't have to write out the sequence all the way out to 88. To the 88, because I could plug in the number 88 and it would spit out the number it's supposed to be. So that's what we're looking at here. So to kick this thing off, the first term in your sequence we're going to call A1. Okay? A1, A being the term, and it's your first one in order. Okay? All right, and then, so the example they're using is 8. Okay, that's what this is about here. So your second term would be A2, and you would get to your value of A2. So if our first number is 8 and our second number is 11, what's the common difference there? 3. So you're adding 3 to it, right? Well, your common difference is 3. So to get from A1 to A2, you'd take A1 plus the common difference to get your A2. Okay? So what's the next number going to be if this one was 11? 14. Okay. So the way you can get 14 using the same sequence is your third term is your first term plus 2 times your difference. Your first difference was 3. So 2 times 3 is 6. So the difference, or number 1, 8 plus 6 will give you 14. What's the next one? The next value would be, this is just setting up the formula.
I feel like
Okay,
that's
you
gonna-
won't have to remember this
Okay.
process.
I feel like that's gonna mess me up because A3 and then it's only 2D. It's just.
Yeah, well,
Yeah, you don't really have to have the A3. You just have to have.
don't worry about that yet.
I
Again,
get stuck easy. Yeah.
wait till we get to the end, and then you can freak out if you want. But it would just continue. You see what I'm getting at here? So, the nth term. So if whatever term we were picking, you can see up here when we had A2 that it was A1 plus the common difference. Well, at AN, it's still the first term in your sequence plus in whatever term you were wanting. So say I was wanting the 88th term, I would plug in and go 88 minus 1, which would be 87. So there's Quinn's issue. He doesn't like that this is A2, or that this is A3, but then you're taking it times 2. You're taking the common difference times 1 less than your numbered term. Okay?
That's understand.
Don't freak out yet. I did say you could, but you can't. Don't forget it.
This is pretty easy.
It's-
You just add 3.
That's actually.
Here is what I want you to remember. It's the same thing as here, but this is what you need to write down in some notes somewhere. Where do you keep notes? Wherever you do it, get it, because this is one of those pieces of data that I would let you retrieve on a test if you have written down somewhere.
Are they allowed to be on our iPad?
Yeah, as long as it's in notes or notability or something like that.
Wait, get that written down. Okay. She can't see.
If it's
Yes,
written,
I understand this. Can you be?
why do we have a finger?
She's fake.
Oh. Tell her to hold still, Faith.
Hold still, Mackenzie.
You're shaking so bad.
I can't.
Do you have it? Yeah, she has it. Good enough.
I'm just.
Yeah, she has it good.
We're gonna act like it. Yeah. Okay. So writing an equation for the nth term of this sequence. Okay, what is the common difference, first of all? Adding 4, correct? Adding 4, adding 4, adding 4. So our common difference is going to be 4 when we get to that. What's our, we're looking for the nth term of this, so a to the n would be, what's the value of our first term? Negative 12. And then it's plus, right? In the formula. Plus, what term are we looking for? We don't know yet, but we can put n minus 1 times the common difference, which would be 4.
Okay, now you just do your thing.
Then, if they ask on part B for a specific term, such as, wait, right here, wait, got away from me. So what is the sequence? Which term of the sequence is 32? That's a different one. Doggone it. There, ninth term. Darn. So let me rewrite my equation. A to the nth in this situation was negative 12 plus n minus 1 times 4. That is the formula for the sequence. So if we want the ninth term, Parker, where would we plug in 9? I want the ninth term.
With the N?
So we're looking for the ninth term would be 9 minus 1 times 4. You're plugging in that 9, the ninth term, in for n.
8 times 4 minus.
That'd be 9A.
So A would equal.
No, it's just a to the ninth being the ninth term.
22.
Well, 8 times 4 is 32, so you have negative 12 plus 32.
22.
Try again. 20.
Oh, sorry.
So to the a to the ninth term, let me write that a.
Wait. Oh, no.
So the ninth term would have a value of 20. Okay.
Okay, that's not that bad.
All right, now the next question is going to,
Oh my.
don't worry about all that. You're just graphing it. So
Oh.
you plug in 1 for that sequence, kicks out some value, so you already know that 12 was your first term, right? Or negative 12 was your first term. Your second term was negative 8. That was given to you in the sequence, and you just plot those and
Do you even have
don't
to solve
connect.
the rest of them, or just like get the first
I would, it's really, the rule of thumb is get 3. 3 points determine the line, because if you happen to make an arithmetic mistake on one of them and you plot all 3 points, if you plot 3 points and you make an arithmetic mistake on one of them, you're going to get something that looks like this as a line. No, you'll know you made a mistake somewhere. If you just do 2 and did that, well, which one was right or which one was wrong? If you put that third one, it checks it for you, basically. So yes, do 3 of them, and that's fine. Okay. Now this is the one I think is pretty cool. Is which term gives you the value of 32? So our equation, again, our formula for this had been an equals negative 12 plus n minus 1 times 4. Now when I was looking for the 9th term, Corey, I plugged in 9 for n. Well, on this one, I want to find what value of n gives me a value of 32. So I'm going to have 32 equals negative 12 plus n minus 1 times 4. And then we're just going to solve this. I'm not even going to distribute that through yet, because I'm going to first just add 12 to both sides. 44 equals n minus 1 times 4. By not distributing it through, now I can just divide by 4 rather than having to work it on out. Okay. So divide by 4. You have n minus 1 equals 11. And you add 1. You get 12. So your 12th term would spit out the value of 32.
You understand it?
So there's really no point to the graph.
Huh?
Is there even a point to the graph?
We'll
The
explain.
graph is just recognizing that your first term
Well, we
matches
have to
up
do
with,
that.
so not much. Huh?
We have to do that.
I don't remember, to be honest with you, if the graphing is a part of it or not. I'll look it over and we'll talk before I'll give you my expectations.
15.
Okay. In Notability or on scratch paper, what is the arithmetic sequence or the equation for the arithmetic sequence of this? Write it down. Well, that's the common difference, but that's not the equation. Well, that is the general form. Now plug in the values that work with.
Oh, fabulous, sorry.
Wait, do I?
Oh, are we finding it for a graph?
We're just creating the equation itself.
I think I'm
So
gonna.
you're fine.
Wait, do I take it out? Corey, is that even close?
What is the value of your first term?
Simplify this. How'd you get 28? 28 is
You actually want to go one.
Yeah, it's my last.
Yeah, you're not supposed to be last, you're supposed to be first.
I got it.
I don't. Why can't we just know them add?
You have to add to
Hmm?
n. And you have to multiply by
A1, which is the first value, the first
by
value of
d.
your
D
term.
is however much it changes.
What if you already know
Okay.
it? Just know
It's a good,
Times
hold on just a second here. I maybe need to clarify this a little bit. A1, and I don't know why they use A, but A1 is the value of the first term. Okay? N is the number of that term. So if we're going to put in A1, the value of A1 in this problem is 1, then the value or the term number that is 1. So this is your, as a n value, this is 1, 2, 3, 4. As an a to the n value, this is a to the 1, a to the 2, a to the 3, a to the 4. Are you with me on that, Kaylin? Okay. So the n is simply the number of degree term this is, or the fourth term in that order. Yes?
I'm just saying I've
Got it now? Let me see if I can get it. So we're looking for the formula, so I'm going to have a to the n. The value of my first term is 1 plus, and n minus 1, that's always. And then the difference, the common difference, is 9.
Okay.
So everybody good with that?
That's what I got.
We're going to get 9. You came up with 9 just a little bit ago.
got.
Common difference is 9.
Did we ever?
So
That's
can
what
I-
the D stands for, is common difference.
Can we just
Do we ever
understand
use
that
it?
it's plus 9 and figure out the next
That's
one?
fine as long as it's, well, not if you wanted the 3,000th degree term. You wouldn't want to have to write all those out, would you?
Just look it up.
Uh-huh. Now, I am going to copy this, gentlemen. Maybe. Copy this. No. Jerk. There we go. Let's copy that then. All right, so the next one wants to know what our 12th term is. Edit, paste, then 5.
Oh
Ah, forget it.
Is this entertaining?
A n equaled 1 plus n minus 1 times 9. Okay, so that's our formula. So our 12th term. What do I need to do to find my 12th term, Ashton?
Dang, it's so close.
Huh? Put 12 in for n. So I'm going to have 1 plus 12 minus 1 times n. 1 plus 11 times, 9. And 11 times 9 is 99, which is, so the value of the 100th term, or the 12th term, would be 100.
I'm a freaking wizard.
Yeah.
You're a wizard.
Then graphing this, graph the first 5, you're just taking your first term has a value of 1. So 1, 1, 2, 10, 3, 19, 4, 28, 5 would be what? 37. Okay. And you'd plot those 5 points, that's it. Okay, so now in this same sequence, a to the n equals a to the 1, which was 1. Which term would be the term that has a value of 172? So where do I need to plug that value of 172 in for me? The AN, because that's the value. So 172 equals 1 plus. Again, you could distribute the 9 through, but then you're going to have to undistribute it. So I'm going to leave that alone. And I'm going to subtract the 1. 171 equals n minus 1 times 9. Not yet. I would divide. Divide by 9.
By 9 equals 19.
19? Okay, so 19 equals n minus 1. So n would have to be 20.
My God.
Who?
He looked at me like.
My goodness.
Yeah, I did.
My goodness.
No, he said he's not a.
Oh, he's not a god. Oh, I think so. Oh.
I did.
I'm a wizard.
All right. Ugh, what is all this?
How do you?
Something we should skip.
No reason.
Yeah, something that we
Oh,
should.
something we should
No! What's
That is
we get out of
too
this
many
concept?
letters. Why? The algorithm.
Okay, in short, they're saying this, that an arithmetic sequence is going to give you a linear relationship. Okay? That's why when you graph it, they were putting the graphing part in there. Where the n is your independent variable, your x, so to speak. It's the number we put in, and then it kicks out some value. And then they're saying d is the slope. Now, what value did we use for slope on direct variation? Okay. But I'm typically going to use m whenever we see that. But anyway, if you reordered, you can show your formula as this. F of n equals that. Now, I'm trying to think. Let's just move on here and see what we're up to find what the point of this is.
Quit.
Is there a point?
What's he doing?
Is there really?
Being a distraction.
What did I?
Marisol is mailing invitations to her. Somebody say that for me.
Quinceañera.
Thank you. The arithmetic sequence is this. That represents the
Quinceañera.
cost of postage.
How do you know how to say that? That's
Quinceañera. Have you seen McFarland? The movie McFarland?
Oh,
Yeah, that was a good movie.
When they're getting ready to do her quinceañera, however you say it. Okay, so first we want to write a function. Now, what is different about writing a function from an equation from back in lesson 2? An equation, we did y equals 2x plus 4 would be an equation. How would we show that as a function?
The
Oh my goodness.
F of
X.
x equals.
we're back to this.
We are back to
I
this.
thought we started a new lesson.
We did. Now, what we use today is a sub n,
Oh dear.
a sub n sub a subscript n was a sub 1 plus n minus 1 times d. Well, rather than writing, this is essentially what our y is a sub n, but rather than writing it as a sub n, we're going to write it as f of n.
Whoa.
Oh my.
What about F of X?
Oh, since you're not
If we were using x.
X.
But remember, our n is the independent variable, and so the resulting range or the resulting part of that would be your y. So going back then, our equation will look like this. F of x, sorry, I just did it wrong, didn't I? F of n is equal to, what's our first value? 0.42 plus n minus 1 times, what's the common difference?
42.
It's also 4200, isn't it? Or 42 cents.
Why do you have to do that?
Why can't we just,
Why
like,
do you
what
add
is this?
more letters?
I didn't add more
I
letters.
didn't add any.
Wait,
He just,
where'd the F come from?
he substituted.
Oh my.
So they,
Are you sleeping in this class?
No, I just don't get it. Why do you have
Okay.
to do it?
Well, I wasn't, I still get it.
In chapter 2, we talked how the value of, we could change y equals something to be f of x or f of something.
Oh, yeah.
So that's all I did here is I took, and instead of putting the a sub n,
Oh,
I'm rewriting f of n.
okay.
Okay? So there's your equation for that, or your function in this situation, because we're writing as f of n. Okay? What's the next one?
That's a big cow.
does anybody know what time we get out of this class?
15.
Who cares? Alright,
John's like 50.
the graph
15.
is to determine the domain. You can plug in 1. When you plug in 1, what do you get? What was the first term in your sequence? 42 hundredths. So 1 is 42 hundredths, 2 is 84, 3 was whatever, blah, 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 blah. Just plot those. Okay? So the domain, it represents your ends, is this. Does it ask to determine the domain? The domain is 1, 2, 3, dot, dot, dot. Now it's a mailing. Can you have a partial mailing?
No.
Can you mail part of a postcard? No. So that's why your values would be on a solid point, because you're not able to sell a part of it. There's not a solid line connecting them. I think we must have skipped some. So what would the value be to mail, let's say 40 postcards?
Oh, no.
Who needs
Now
to
what
know
was
that?
our, so basically I want to know what f of 40 is when we had 0.42 plus n minus 1 times 0.42. Okay, what's n minus 1? 40 minus 1 is going to make this 39 times the 0.42. Anybody have a calculator doing that for me?
Sure.
Oh, so you just plug 40 in for
Uh-huh. Just plugged, I shortcutted that. I should have written that down so you weren't confused by that. But
38, yeah.
16.38,
Nice,
right?
hair shape.
Why can't we understand that it's just adding 0.42 and why can't we just say that? You're just adding 4.2.
You are.
You have to go, like, why do we need all of this? Why
Why
can't we
do
just
we need all this?
understand that we're just adding 4.2?
well, you are, but you can't get to the 40th term unless you go 0.42, 0.84. You write them all out.
40 times.
But
Yeah, I'm
who
pretty
needs
sure
40 postcards?
I'm pretty sure Faith is,
Maybe you're going to go to a wedding.
You're on mute again because I can't hear you.
Maybe you're having a wedding and you need to set up.
It's not like people are talking.
Just say it's
I have to show you this.
Now, what if Arlie, when she is getting married,
Who's Arlie's getting married? She's not going to be married.
Quinn.
She's not going to be lonely.
Quinn.
do you not have one right
No,
now?
it's Quinn.
This one?
Wait, guys. Yes.
He likes someone else.
Sorry to bring that up. Anyway, let's say Arlie, when she's getting married, her parents say, hey, we've got $100 that we can spend on postage. So then, how many invitations or how many postcards could she send out then?
Not very many.
We're still going to be looking for, our equation is still going to be n.
238 minus
No drinking or eating in class, mate.
Is that your class?
Bram. Excuse me. Bram. She has $100.
So
Where would I put the $100 in this equation?
we're in
Are you sure about that?
F.
F of n.
That's your final answer.
So you have 100 equals this stuff. Subtract 42 cents to get rid of this.
And then divide by 0.2.
That would be 99.56, sorry, 58 equals n minus 1 times 0.42, divide by 0.42. Gonna have to get a calculator on that one.
Oh, this is gonna be.
99.52 divided by 0.42 equals 236.95238.095. Okay.
You said 0.23, 0.023?
No, 0.9. Oh, is it 8?
Yeah.
Oh, it's 8 times
Not me.
2. Okay.
So it's 273 or 237.095
Yeah.
equals minus 1. So you can add one more to that. Add 1. So that would be 238 point something. So she has enough to order 238 postcards to mail them out.
Why does
You
she
know
need
that
that
many
many
people?
postcards?
Yes.
Okay, wait.
Why are you inviting that many people to your wedding?
Well,
Oh,
you
did
can
you just
invite the
round?
rich people
Yeah.
and the people you like,
Because
So they can give you
and then your family.
this was the exact value.
Probably be
That's the exact value. We can't have a decimal value of a postcard. Yes, ma'am.
Why couldn't you just take 100
I wonder if you
divided by
could like cut a
0.42?
stamp in half.
Yeah.
Okay, what is it?
What if you cut a stamp in half
288.
and then
Hmm?
put in half the postcard with half?
Because it
I've
still
tried.
costs the same.
And half
Oh,
of
they
the-
just proved
and
that.
half of your day just put
100 divided by.
Still
your
costs the
last
same.
meal, half of your address 129 cents.
48. Where'd you get
Half of
48?
yours is
You could in real life.
Where did that? So why can't we do it now? Why can't, where did you get 48?
It's still
40.
Because it
From
doesn't
the
deal with
numbers.
sequences.
Everything that you have to
I
do.
think there might be
Besides,
more
it's not
letters
like
than
people
there
have
is
these
numbers.
They did a big slides, right? Trucking the
Yeah.
numbers.
Literally.
Why can't we do like
The multiplication sheets.
oh wait, we can do that now? Okay.
Making a function.
F of A.
Okay, so do F of A. No, F of A.
F of N.
It's plus 11.
F of N. Thank you.
Yeah.
You're welcome.
Your apology is not accepted.
And then a number which would be 12. Wait, so what are you, what are you looking
And your
for?
change is
Oh
11.
yeah, got it.
Difference is 11.
Yeah.
We don't have a value for n yet. We're just setting up the function.
And it'll tell
We're not
us the
solving yet.
next
I get it.
problem.
So the next one would have said something like, this is how much would,
83.
something like that.
Yeah. And then you plug it in for N and then do your thing.
So yeah, if you said 83 newspapers, what would the weight of 83 newspapers be? You put in 83, 82 times 11 plus 12.
I want to figure out. This
Have 5 minutes. Read.
no. I have a question.
Too late.
Faith is confused.
Now we have 5 minutes left and I need extra practice.
No.
No, she isn't. She just said watch Moana.
Do we have to have homework?